all seem to make it here. And I asked Hiram if anybody showed up last night. He doesn't think so. So
I was here until 7.
Yeah. So fortunately, that's good news. We're talking right there. Oscar, right? I should have remembered because my brother-in-law's same name, and I was like, my brother-in-law's name. I'm going to remember it, and then I didn't. Sorry. But Oscar, I think his group's going to be our presenter next time. But any of you, if there's people at your firm, I'm always looking for presenters. So if you guys want to present, if somebody at your firm wants to present, we obviously prefer live face-to-face, but we're not against doing it through GoToMeeting like we did with Zach. I've got one or two folks kind of on deck for that, if I don't have anybody some month, but I've been sort of putting them off because I think you guys like it better when we're all kind of face-to-face. So anyone have anything they want to add or comment on before we jump into our presentation? No? All right. Well, of course, thank you to Thornton Tomasetti for hosting us. Thank you for being our presenter. Hiram Rodriguez, it's tripping on my tongue here now all of a sudden, is, okay, so I'm going to read his bio here. He's part of the Core Studio, which is a firm-wide virtual incubator of ideas. I love that. That's like, is that on your business card?
It should be in a t-shirt.
Chief Incubator, The studio coordinates R&D, develops custom software and apps, designs workflows to optimize project realization, and develops computational models. There's a mouthful, right? That definitely should be on a t-shirt. As part of the Core Studio, Hiram is involved in different projects ranging from stadiums, tall towers, R&D projects, drones, and photogrammetry, and complex geometric optimizations. He has taught Dynamo at Facades Plus in New York and Kansas City. Is that like a conference, a school? What is that? Facades Plus.
Facades Plus is a conference.
Yeah.
And
okay. And then tonight you're going to be showing us to use Excel data for structural software to overwrite elements, parameters such as column size, forces, custom foundation piles, and create full rebar plans, and also present ways to use Rhino and Grasshopper to automate design, translate geometry via Dynamo, unless you've changed things since you sent that.
There's some of that in there in the presentation. There's some other stuff.
Well, feel free to show us whatever you like. So thank you very much, Hiram. Take it away.
Yeah.
Oh, and don't forget to click record.
I think it's recording.
Okay.
Should be recording right now.
Great. Oh, yeah. Did you do share?
Is there somebody there?
No, but I don't think it'll record your screen if you don't do share. Yeah.
There you go.
Very good. Thank you.
Nice.
Because otherwise we'd have sound only.
We have a GoToMeeting expert right here. It's just basics, right? Just basics. Yeah, well, thank you. Let's see. So yeah, if you're not familiar with our practice, so like I was telling Paul, we started as a structural engineer firm. Now we expanded to 10 different practices, ranging from facades to protective services with the Wylander office, as well as other things, right? We do sustainability, forensics, structural engineer. For the most part, I'm involved with facade and structural engineer, but we do work with the other 10 practices here. So we have offices in 54 countries, and we're about 1,200 people. This is ranging from engineers, architects, you name it, to different types of expertise. So the work that we do with the Core Studio has to encompass, or at least try to do justice for all these different folks in the company. So Core Group is just a computational research group. We're about 12 folks. Mainly they're all in New York. Me and there's another guy in LA. There's a different backgrounds in this group. Some of them have architectural engineer, others have computational backgrounds. So they build software development. Otherwise, there's one guy who we hired last year. He is the main developer for our Autodesk applications for Dynamo and some of the online applications. And there's some artists as well, background artists. So we have a range of individuals within the group, all with the interest of doing computational work and doing all this that we're doing. So some of the things that we do in the group, so geometry rationalization, we do fabrication modeling, We do integration building analysis. This is like building platforms in Grasshopper and other softwares to do analysis and have this automation. We do software development. We've been doing a lot of work with Dynamo, Grasshopper. So if you want to download this information, Food for Rhino would be a good avenue. We put the software out there. It's for free. Most of our Dynamo add-ins and plugins are free as well. We do a lot of work with Autodesk, and anything that gets built in the additional releases, we put some input. So if you have inputs, if you know something that might be interesting, you can go ahead and send me an email, or I can give you the email of one of the guys in our group, and you can say, okay. We have an internal tool called TTX that allows us to interpolate between different platforms. This tool will allow us to bring, elements from Grasshopper to Revit to Tekla to all these other platforms. So it's a platform that we have for the past 4 years. And I'll show you at the end that this is migrating to a platform that you can be part of now, that you can be a beta test and install that in your machine. We do a lot of research and development. I'm part of that group as well. We do a lot of photogrammetry. I'm sure you've done some of that. Drone. We're getting involved a lot with 3D printing with some companies here and some other ones in research in schools. We've done work with this company called Branch Technology. I don't know if you've heard of them. So we design things with them. So it's pretty exciting. We do a lot of physical prototypes. Actually, we're not doing that anymore. It's pretty time consuming. We do training, and we do hackathons as well, and symposiums. And we also do specialty projects. So like we work with a lot of artists that have not regular projects to work on. So feel free to go ahead and go to the Core Studio website, and we have a Twitter account. I think we have a Instagram account. I don't manage that. We have somebody, so I don't know what gets put in there. But I know that if there's a post for a job, or there's new things, they'll come up in here. Our Core Studio page does have some of the things that are going to come up in Dynamo 1.2, and this is all work by Max, the guy who I told you is a Revit guru in our group. And some of these we're implementing right now. Some of the work that I've done with the group and the company is just quick highlights of this. Is sort of like small prototype models and physical analysis to a little bit more mid-scale complex modeling and fabrication to something a little bit more larger that I get involved. So there's a range of things that the group gets involved in the firm. We have a pretty good portfolio of different, going from tall towers to very small work. So it's always interesting to get involved in those. And lately we're getting involved more in how to use Dynamo to automate some of these processes that engineers are finding to be tedious, or our drafting folks are finding to be easy to like I said, create a rebar plan from Excel and then automate that process. So and I think it's a good platform to explore in the firm. It's pretty user friendly. I think my background is architectural, and I was pretty good at Grasshopper. So for me, it was kind of like a good platform to work with. But if you're starting from scratch, I think it could get a little complicated. But it's pretty good, self-explanatory the way it works. So the 3 things I'm going to be touching today in this meeting will be automation, 3D, 2D, cross-platform documentation, and how we're using TT in Dynamo, how we're using Dynamo and TT as a community, right? So at the end of the day, we're 1,200 people. We want to be able to at least reach most of them, or at least some office, so they can do the same thing. So not only us in Chicago or New York are doing the work, and you want to have everybody in the same ecosystem to work with. So the first thing is going to be automation, and this is work we're doing with Bentley software. So some of the software you might not her because I mean we use it for structural engineering. But this Bentley platform allows us to build models that are going to be for rebar, right? So we can analyze buildings and create rebar plans out of it. So at the end of the day, what you have is this, and there's two ways to do this. You can explore, or you can have somebody draft this, right? In the old days, it was okay. So we got this plan, we got this number of rebars, and you need to expand this so much, and go ahead and do it. So we're trying to find ways to automate this process, and the way we're doing it is through Excel output from these platforms and using Dynamo to read those Excels. We've built a couple of custom add-ins for Dynamo to read and interpret some of this information, but for the most part, I would say like 90-80% of this workflow is out of the shells nodes from Dynamo. There might be a couple plugins there or Python scripts that we've built. But this started from from people being frustrated that they needed to change this plan, every time there was an opening or there was a different program added to the building, right? So every time you do this, you need to run the analysis and then change that, right? So the output we're using is an Excel output from Bentley RAM concept, running this analysis, reading this Excel information, and obviously you have different tiers or platforms that you need to apply this information into. So we built a custom family. I think one thing to take in notice is that to take the most advantage of Dynamo is try to build your own. This is what I've learned so far. Try to build your own families that can do something that you want them to do, right? So in this case, we're building families that will read the Excel and create a whole floor plan, right? And we'll read that Excel and tell me whether or not it's a 90% hook or it's expanse or what is the size of the rebar. So if you can build that out, I think it's very useful. And this is only, the output is in Excel, and I'll show a video. I have videos for all these presentations. But the basic output is just Excel, the level, and that's it. You read the family, put it up there. So I'll show a video of it. So like I said, this is a lot of this work has been done by our folks in the DC office. So they've been doing a lot of work with concrete design and buildings. So right here, I'm just looking at the different outputs. So I'm just reading an Excel, reading the work section of Excel, the level where it's going to get applied, and then a Boolean true or false. The rest of the definition is built into top rebar or bottom rebar for the plan. And at the end of the day, it's they're creating detail groups, and we're grouping them according to according to the date. And at the end of the day, if you need to change that, then you can delete that group and just rerun this application and create that that plan again. So right now, it's just going through the process of reading the Excel, and you'll see in a second how this works out.
This is one floor at a time.
This is one floor at a time, but I would do it one at a time. Yeah. You could probably automate that process, but you want to look at what the outcome is and how that works out. So right now, I just read the file, and it creates a group, and it automates the placement of the rebar. So one thing that you can take away from this, I think, is that you can do this in plan for documentation, but you can also do it for 3D. You can actually draw the rebar if you wanted to, but my experience is that you don't want to do that. If things are going to be changing all the time, you just want to create a detail group that allows you to tag it with the correct rebar size, and if anything changed, just change the Excel again. So this is just showing the extent of where the rebar should be placed. And at the end, like I said, it was just creating detail groups with a date when it was developed. This was useful for other people to see when the rebar was placed. For some of these models, if you're doing this automation process, you want to be able who did it and at what time did they did it. So at the end of the day, this is sort of like the output of the process, and then you can share this. I think this was in construction document. So we were doing this for this project. Yeah.
Did you create those mesh families, like the? You just draw the lines, or see how there's the four?
No, you could probably, if that's an output that you can probably read, then you can do it. But for now, the extent of the design was to just annotate top rebar, bottom rebar hooks extension. So, yeah. If you have any questions, or if you want to stop me in some of these, it's fine. Just do it. JJ said he's a structural engineer with our group here. He's in charge of the tall tower design. So if I show some of that, he did this.
So you're a plant. I'm a plant.
So if you have any structural engineer question, you can ask him right here. Free consultancy right here. No, it's pro bono. Yeah.
Sometimes the tags in that program are overlapping, and you have to move the tags around to kind of make it look right. Do you have to do that in like the program first before you run this, or how is the tag set up?
The tag set up to a that's good. We set up according to the file to the model, right? For one of these files, you can set it up either to be at the middle, or you can set it up to be at the end or at the edge. So you have that flexibility to do that. But yes, I understand what you're saying, whether or not, if you have this like rebar placement, then all your nodes are going to be on top of each other. So, and that is something that you can do it within Dynamo. Sorry if I say grasshopper sometimes. That comes out. Bad habits. So yeah. So the other thing that we're doing with Excel is getting information for tall tower design. We've been involved in a couple of projects here with the group here, and some of the idea is for this is how can we take these core walls and automate the process of them, put them into Revit, right? So for the structural engineers, if you see the walls, they have to be split at every level. So they have walls at every level, right? So whereas Revit and your documentation is going to be from point A to point B, right? But for some of these models, the problem also is that the walls are tilted and they have a slope, right? If they're complicated enough, or we have a project where, some of their walls are going backwards or have a tilt. I know it can be a little bit painful to draw those in Revit, so we're trying to find ways to do that and also assign the correct family to the walls. And at the end, it's finding this kind of situations where you can get an Excel output from that platform, and then starting playing around with creating planes and faces that you can then use to create walls. This is something that is still ongoing, but we made a progress. This is something that's going to come up soon in the new release for Dynamo. So you can create walls from faces. So if you can create a face that is like, let's say, Richard Serra sculptures, right? If you can create that into a sort of like weird shape and import it into Revit, then you can select and create a wall out of it, which is going to be, it's going to read better in your plans, and you'll be able to tag it and do elevations and all of that stuff that needs to be taken care of. So another thing that comes out of this Excel output from the engineers platform is that you get the section property of each of these frame elements, or shell elements as they call them, and you get a location of that face or wall. So we're taking that into Dynamo and start to automate the placement of those walls with the correct size, and at the end, sort of like just having a color code of those elements that got developed or got created. So not only the engineer, but whoever's using the model can see that a color represents some sort of logic. In this case, it's based on tiers, but for this example, we're color coding them at the end based on wall type. So one thing that came out of this workflow was using group by keys in Dynamo. If you haven't used that, it's a pretty cool thing. So if you have let's say 200 elements of the same type, and you have 3 types, then you can group them according to each of those types. And then that way you can just create your walls, whatever, facade. So if you have a facade and you have 3 different panels with the same type, you have an Excel that is all your facade types, and then you can automate some sort of processes that can take those types and group them and change them according to some parameter that you want. So this basically is doing that process. We're taking this Excel output and then reading that Excel into Dynamo. And like I said, it's all we're using here is out of the shelf nodes. So we're using the one that Excel reader from Dynamo, and the wall created by Line from Dynamo as well. So, and just to know that once you have this, you can create groups, and then just it's a matter of seconds to update those walls according to if the model changed or there's different elements that need to get thickened up, or or the architects need to see different changes on them. So, and this is just going through it. I think I'm using one element here that duplicates families to create my walls. So in this, it just creates all the walls, and it gives you at the end of the definition a color code based on thicknesses. So you'll see that the major thicknesses are going to be the red ones, and your thin walls will be in blue or cyan. So you can assign this, and you can just create some sort of template. If it's consistent, then you can send that out to your staff and say like, okay, so this color's been this color's been that. Every time you see them, So this is what I was talking about. Once you have that, you can group them by a certain type. So I think that's it. Another thing that we're using this to automate is this kind of work for pier drills, and this kind of like annotation in plans. So this was a project that we have in house, and one of the tests was that the pier needed to modify the drill information, and the top of rock was changing, and some of these forces had to change as well throughout the project. So again, this information is what you end up having, but to change this, you have to change, let's say, 5 or 6 parameters per element, right? So the way to do it is to, again, use Excel. Most of our engineers are pretty well versed in Excel, and they use it for everything. So sometimes you have to leverage how to use those platforms well. So they had already a pretty good Excel platform Excel file that they were using to automate some of these inputs, but they were just lacking the process of bringing that into Revit, and using Dynamo was one of the options to do so. So at the end of the day, you can see that the pier family had different attributes, and you can add your own attributes now, project parameters and share parameters to the Revit using Dynamo pretty easily. So we were just adding element parameters that we can change from an Excel output. One thing that we wanted to have was the element ID. So you always want to find that element ID. You can find the GUID of the element, put it in there in Excel. But I don't know if this seemed to work well. One of the things to notice here is the way formatting the structure of the output. If you want to format something that's I'll go forward. If you want to format something that has a title, all the elements of the title and then the output as such, the way to do that, I don't know if you know this, is to use a transpose of the data and add all the elements that you're looking for at the beginning. So that will generate the way a structure Excel that you can use. Then we're just exporting that Excel to Excel, and then adding some additional parameters that the engineer can just easily change. And once we had those changes, we can read the element ID and make sure that the element ID matches. And once it matches, just change that those parameters. So you would only have to tag it once, and then all you have to do is just update the pier based on Excel. So any group that you see here is just looking at each of those parameters that needs to be changed. So you can do it individually, or you can do all of them at once. So that's up to your user.
Is that the built-in Revit ID, or you're devising your own element ID?
No, that's the built-in Revit ID. I could say it's like I think Conrad or some other guys give you the GUID, and some of the platforms that we have in house, like TTX, actually uses the GUID of the element because that does not change at all. There might be a thing where the element ID might change, but the internal ID of that element will never change, and it's always it's like it's DNA. So that's something that if you want to be hardcore about it, just use that. But if it gets deleted, if anything, then element ID, yeah.
How are you doing the selection then? Is it just through Excel, like it's reading the element ID from Excel, and then you can script it to find those elements based on ID?
Yeah. So all you're doing here in this definition is reading the Excel, and in the previous, I don't know if you saw that, but here one of the parameters is the ID. So I already have the parameter ID in there. So all I have to do is just call out that parameter back again and make sure that's the one that I have in Excel, and then just put whatever it was in there.
Does it recognize it just as element ID in the name of the parameter?
Yeah. Whatever it says in there, that's whatever you're gonna have to write.
Did you make like a master list beforehand or something, where you
No.
used, or was it by points, like points on one like analysis model or something? And then
No, what do you mean by points and ones?
just like, well, I'm guessing those forces and stuff come from some analysis model, so those all have some sort of IDs associated with them.
Yeah.
Or did like, what was the process of somebody like? Did somebody just like go through at each point and then make some sort of master list to?
There was a mapping exercise in Excel where you had to take those forces. So there's this pier mark had already been in another Excel where all the forces was already tied into those. So once we brought some information of those references into the new Excel, we were able to just match those back. But yeah, the engineer had to do matching in Excel, which is pretty straightforward, I think, for some of the things.
Sure. I was just if you had so many, like I just was wondering if you did something a little smarter, where you just like you took the point coordinates or something from the analytical model and the point coordinates that you got.
No, because everything what they did was the way they were doing the analysis or the forces was a lot of Excel work, and some of the work may have not been through coordination, because some of the models are not coordinated in the same location.
Right.
I've seen that. So,
and
it's pretty typical to not have, and it will take more time. But yeah, at the end of the day, it's we added a couple parameters, grid XX and grid XX, and updated those elements. Good, kind of. So the next thing we're doing is Bluebeam and Dynamo. This is a plugin that just came out a couple of months. Again, the guy from our office is doing this on his own. It's called Dynamo Bluebeam or Dynamo PDF. So he's using it for some other stuff. I started using it for some other stuff like notations and markups. So we're trying to find a way to see if there's a better way to annotate our sheets and our details if anybody has to change that. So we're using this platform to kind of see if this flies. So for me, I've been using it, and it's pretty straightforward, and it creates pretty good legends, and like you can tag, and you can create clouds, and you can create all the text. So I guess this came about because some of these, I was working on a project and I was getting frustrated that some of the notes weren't getting put in incorrectly. and there was misspells and all that stuff. So at the end of the day, you want to be able to check that this information gets put correctly, and you make the life easier for some of these folks. So we're trying to use this to automate this sort of like placement of notes. So in this part, we're just reading the PDF. We're looking, so the PDF, the definition is, I don't have it open, but all it does, it takes all the information from that PDF, all the line work, all the notes, and you can extract that in Dynamo and use it for your own goods. Like I said, Max, the guy who built this, he was using it for more for building masses. So if you have an architect, if any of you guys use Bluebeam and you start sketching elements, then you can take those elements and then do some sort of a massing if you want, or openings or whatever it is that you want to have. I'm thinking more of how do we implement this into the BIM staff, right? How do we create some sort of workflow that they can take all the plans and then just automate the placement of text or clouds in the sheets. So here's just reading those, it's reading the Excel file, the PDF, reading the cloud, the text, and I'm using different colors to differentiate the things that I want to have in Dynamo be written. So all I have to do is select the ones that I want, do a simple filter by Boolean, and then just filter those things out. So one of the things you can also read in the Dynamo PDF, I should say, is the content, who did the changes, what date, and color. Right now it's also reading subject content. So if you put, let's say, a line and you add a comment to it, you'll be able to read that comment. So once you have this, use current nodes by Dynamo that you can add text, and all I'm doing is placing a text in a point within the sheet, alignment, horizontal, and the view. And I'm also doing a revision cloud, because I know my PDF has a revision cloud, and this is already part of Dynamo. And you can add whatever revision is in that present model. So once you have that, add that revision, structure this, all you have to do is run the definition. So I gotta say that this, it's a little bit, you have to customize for your project. I found that it works pretty well, but you have to first define the definition within the project scope, meaning like what are the sheets, where's the revision cloud's going to go, what kind of tags there's going to be, what kind of text you have to use for that project itself. So at the end of the day, it just creates all this, and then you just have to, it doesn't read it as paragraphs. The only way to do it is if you do a long text. So if you do a paragraph in Bluebeam, it will not read that for some reason. That's a bug. But it only took a few seconds to do this, and I know it's the correct thing, and I think it's just kind of cool, because we were talking about this last year, whether or not there would be a plugin for Bluebeam that will read line work, and people were very scared, like, oh shit, people are gonna be doing this and then it's gonna go crazy. Like they're gonna do it incorrectly. But if you think about it differently, I think it could have a good potential. It all depends how do you use it. We're using it for this. I'll show another example where I just used it recently last week for a deadline where I was helping a team, and the process, and this screen comes all the time. This is the only free thing that I'm not advertising that. So we're doing clouds, tagging, but this came out the other day. I was helping this group here in the office, and we had a deadline. And the roof of this cladding for this building is not straightforward. It's not flat. It has valleys and it has curvature and all that stuff. So the engineer drew this, and I work with them a lot. And so I was like, how do we make this process a little bit more smooth and we see the outcome before we put it up in Revit for documentation. So again, we use a couple of things, right? Just use the grid line to get some scale correctly, dimensions and stuff like that. But we use Dynamo, again, the same platform for Sandbox instead of for Revit. So if you're familiar with those two, standalone and the add-in, right, for Revit. So it works the same for Sandbox, which is the standalone. So I'm just reading this information straight from the PDF and using Rhino to create a line work out of it. So the way I'm using this is because I want to reference this geometry before it goes to Revit and be able to create something that, like I said, it's not such a straightforward model or building that I need to reference that to a specific level, extrude that, and make sure it doesn't hit the cladding, and that we have clearance for the gutter and stuff like that. So I work a lot in Grasshopper and Rhino, and the best platform for me is to use it. So we're trying to use this, and this is just a video of how we implemented this. So it brings everything. I mean, I could ask the engineer to color code the moment frame or the girders or major elements, and I could just have that be a layer in Rhino that I can then just use. So here I'm using the same process, and here you can see that you can read the entire PDF. You can read all the text in there. So there's like all the grid lines, information, construction, project information. You get the colors and you get the nodes the same way as the other one. So this is, if I go back, you'll see what I'm saying when it's, if you see this is pretty buggy right now. So it's like a paragraph and it doesn't work pretty well. But that was not my concern. My concern was to get this geometry as soon as possible to Revit and have it coordinated with the architect as well. Because some of this was going to go that same day or the next day to the architect for coordination. So at the end of the day, we just took a bunch of lines, converted that, and then created a Rhino model with the exact dimensions. Once we had that, you get a flat model, right? So that flat model then you can use as center lines for your structure. All I'm doing is project into a surface, offsetting, and applying some sort of a section that I can see. And you'll see the second step is that. So at the end of the day is this. It only took, I want to say, an hour and a half, 2 hours to produce this, that I can actually reference I exported a PVX from Revit to reference my geometry and actually see what's going on. And at this point, we saw that some of the geometry had to change location, and we were pretty off from the cladding, so we had to, revise our structure. So in this, you can see the cladding and the different geometries superimposed. So, it would have taken a lot of time somebody to draw this in Revit and then find out that it didn't work. So we want to look at this prior to that and say, okay, this works. We'll just bring it in the way it is, and then we'll deal with it in Revit as soon as we get it. Because somebody tried to do it and it was like, oh, we got to build all these planes and all this stuff and offset from plane. I was like, okay. So I think that this is something that I don't know if it's useful for you guys, but for us, I think we found something that we can find it to have some use.
So that started as a 2D sketch that was just annotated with the heights and so forth?
No, it was never annotated with heights. It was just a 2D, and we already had a model that had the cladding from the architect.
Okay.
So we already knew where I had to project my geometry to, and then offset from there, and then just draw a topo steel of the beam, center line.
So there's two inputs. There's the 2D sketch and then the Revit model.
Yeah.
Okay.
And then once you have that, it's a matter of checking the model. Because the worst thing is checking the drawings and making sure the thing didn't work. And it's like, oh, now I have to move all my frame a certain distance. And it doesn't work out. But yeah, we're trying to find different ways to make this happen. And a lot of our engineers are a lot of our staff are very well versed in Bluebeam. They like to use it a lot. Everybody here, and so if we can tag into it and try poking around, and
let them use what they want to use.
yeah, you gotta I guess conform to those things, find better ways to use it. Any questions? No. Okay. We'll go. I have a couple of things to show. This is work we're doing with sustainability here in our firm. So we got a kind of decent group of sustainability folks here, and some of the things that we're doing with them is based on carbon footprint and some challenges that they need to, I guess, meet for, I don't know if you know this, AIA 2030 carbon footprint. MIT has another benchmark, so we're part of that. So one of the things that we're trying to use is to collect as much information as we can from all of our models. This from every offices, from 2004 to 2017, you name it. And we need to do it now. Kind of, we can try to build a platform for it, a plugin, but if we can start collecting the information now, it's going to be better. So Dynamo is obviously our platform to pick for this kind of exercise. These are 3 different projects that I work in New York: Cornell Tech, Culture Shed, and another project. I don't know if I can tell the name of that one. So at the end of the day, this is an information that lives somewhere that somebody manages. And again, like I said, that group is trying to find out carbon footprints for every building that we design, and whether or not we're meeting criteria, and whether or not we're doing a LEED certification and all that information. So we're using Sandbox or Standalone to automate some of these takeoffs. I don't know if you guys use the standalone version of Dynamo, but you can do all the modeling, but you won't be able to access the Revit nodes or most of the packages that people write. But there's one that I use for this, and it's from the guy who does Clockwork. It's called Dynamo Automation. So the way it works is that you have a master graph. He calls this master graph in the standalone, that you can open as many files as you want. Revit, 15, 16, 17, you just got to give them. And then what you give is what he calls a slave graph. This is another Dynamo definition that you build to do something inside that Revit. So imagine that you run this definition and you don't want to open 10 files. You just let it run overnight. And what it does is opens that file, opens up Dynamo, reads that information of Dynamo definition, and then it closes. And then it goes back to the next one and back again until we finish the whole thing. So the way we're using this is that definition, and this is the definition that I have for automation, right? It's very simple, right? You just give it the location of the files, the type of Revit, and then it creates sort of like a journal that it reads and it executes. So at the end of the day, I built this definition that just takes takeoffs of the building quantities, right? Tonnages. So we're looking for structural steel, slabs, foundation, you name it, everything. And we're also looking for structural materials, right? So whether or not it's what kind of steel grade, what kind of concrete they're using, what kind of metal deck they're using. So if they're doing it correctly, then the model's going to be correct. But this is something that has worked pretty well. So you can run, if you have something that you're running all the time and you just want to run this, run it through Dynamation. So that's kind of the thing they're using it for. So the output is like this. So for example, for this building, you can either have it, we're putting in outputs of project data, who built the model, what time, what project number it is, who's the project architect, who's the project engineer, all the information that we can. So we have that in the database. But we're also extracting structural slab, right? What kind of slab, where it's located, volumes, areas. So this will help us achieve that kind of goals they're looking for. So once we have that information, I started thinking of how to use that information for other purposes. I don't know if you've heard of this tool called Design Explorer. So you guys users of Grasshopper? Anybody here? No? Okay. Okay, so Design Explorer, it works mainly for Grasshopper, right? So it's something that you can visualize, let's say 400 inputs or 5,000 inputs, and you can visualize this as an input, and then you have some sort of output that you can sort through. So this is mainly an Excel-based application with some images and JSON files that you have to create. So the way I'm using this platform is to actually go through my information and see what kind of models I have. So this is just going to go through a very simple exercise of the page, how that works, right? So this is just doing some facade analysis of, let's say, a module that has some sort of a depth, wind to wall ratio, and some orientation, right? So you can model this and have some output. So what this allows you is to filter to all these parameters and get what you want, right? So you might want something that has, there's a height of 4, but has an orientation of 50, and then maybe has a window to wall ratio of 0 to 4, right? And so it gives you a bunch of options that you can pick from that iteration. And then obviously you can select the one that you want. So this is how it's being used right now. The idea came like, okay, so if we can use this information, why not use the information that we're extracting from those models to visualize something in the web? This is mainly for our project engineers, right, or project PMs, whoever. So let's say that I'm working on a region in, the West Coast. I want to filter through all my projects on the West Coast and visualize which ones can come close to what I'm designing, right? So let's say I'm designing a school that has some sort of parameters. Is there something like that in the TT portfolio that I can access pretty quick? So once we're trying to collect this information, if you can then filter to that information and get to that project and have an output and show right there to the client, I think that's something that we're trying to do then. Since we already have the data, the BIM data, might as well harvest the data somehow. If it's for carbon footprint, then we can have an output here that says, okay, show me all the buildings that are at least certified for the Northwest region that are, composite concrete or steel or whatever, So this is something that came up a few years ago by a group called Case. They used to do a lot of applications for different groups of people, firms, and some of their applications was to filter all the walls or partition types and see which ones are being used the most in the company, which ones are working the best. So it kind of like grew from there. How do you harvest your information from Revit? So I'm pretty sure all your firms have different projects. How do you visualize all those projects at once? That's something that like came out of this exercise. And if you need to do it and you don't want to sit around, just use Dynamo automation from that guy. The other thing that came from this is creating reports. Since we already have that information, I don't know if you've used Power BI by Microsoft. So if you have an account with Outlook, this is for free. So all you have to do is create a table in Excel and upload this, and it will visualize that information for you, which is pretty amazing. So, like for example, this guy, it only took 39 seconds to do the collection, and I think I have it open, so I hope it has open. So all I have to do is upload that Excel to Power BI, and then all it does is it automatically creates a report for you that's interactive, right? So this might be a little lagging. But if I want to see where my concrete, 12-inch concrete is in this building, it's going to tell me, oh, well, all that is in foundation. Well, where's all my metal deck? You can see that most of the metal deck is within these floors. And if, where's all this type of information? And it tells you the volume and all that. So you can play around with this information, It doesn't necessarily need to be just foundation work or slabs, but it can be anything. It could be programs within the Revit. So if you're using programmatic, layouts, you can visualize this as well. Or a facade, if you're visualizing facade, if you have facade parameters that you can override and export them, then you can do that. So yeah, that took a couple seconds. You can share that. You can send that link and go from there. Okay. The next things we're going to be talking is just how we're working with Rhino, Grasshopper, and CAD. So the way we're using these platforms are to, for the most part, complicated geometry that comes my way. Like, okay, can you do something with it? We need to document this in 3D, 2D, and bring it into Revit. Like, okay, so some of the initial things is to do it in Grasshopper and generate a logical typology for that diagram or for that structure, and then share that with the architect. Like I said, we have a couple platforms, and this is called Spectacles. It's free. You can upload your models, BIM models, to the web and share them with whoever. This is free of charge. We have that. This is part of Food for Rhino that you can look for. But anyways, the idea is here is that we were able to share this parametric model with the architect pretty early in the design and pick the one that we wanted and document that in the sheets in the Rev model. For this project, we knew it was going to change. We didn't want to spend a lot of time doing this process. So we used Dynamo to just bring in some of 2D documentation for the model. So this is using DWGs to bring that data. We're using, let me see, BMorph nodes. I don't know if you've heard of this. So there's somebody out there who built that a couple of nodes that will read DWGs in your model. So you don't have to do a container file per se and then explode that and then bring it in. So all you have to do is read the layer of that CAD file and assign it to a correct pen in your Revit model, and then you have a working model. So I'll show that. And let me know if I'm going fast or not, and we can look at it a little bit more in detail. But this is something that gets linked. I didn't want to embed the file into the model, so it's just linked in the Revit file. And you can update as many times as you want, and just take the same layer and just bake it all the time, or create a detail line if you need to. There's no need to do come in, export, and explode things. So this is just using Clockwork to read import data into Revit. And once you have that information, you get two things. You can extract the name of the file and the location of the file as well. I found that it has been a little, I would say, kind of like frustrating trying to look for CAD files in a tower. People will link those towers and link those CAD files to, to indicate edge slab or something else. So with this, you can get a parameter where is the base level, right? So and it will tell you where it is, and that will make it easier for me to go to that level and find the CAD file that it's linked to it. But anyhow, the node, what it allows you to do is to take those layers, and you can take whatever layer in that CAD file and create your 2D drawing out of it. If you don't feed a layer, it will bring all the information from that CAD file into it. And you have the option here. This guy gives you the option to actually create the line work, but I'm using Clockwork, Conrad's tool to do that, and then just read my line styles, pen styles, and then just change that at the end. So for this, I'm just using, I'm going to be using this for my elevation of that structure. And here I'm just reading all my pen styles, right? So you get all your pen styles, you get them by name. And there's already an element parameter that you can change in the line types, that you can change the line style. and all you have to do is just coordinate whatever. We have pretty good standards with CAD drawings. So if I know that structural detail pen 5 is actually pen number 4 in Revit, then I can just match those and then just create that out of it. So yeah, this is important. The only thing that you have to do it at the end once you get the element baked per se in Revit. Once you have that element, then you can change that. I tried using clockwork for this. It didn't work well. It didn't give me the way I wanted to have it work. So it depends on the model, how big the model is and how complicated the model is. That's how much time it takes to create those line styles. But at the end, it's a pretty good. I would say it's a pretty clean process. Once you start exploring CAD drawings in Revit, you will bring all the junk that's in your Revit model. So at the end of the day, you don't want to have hatches. We have instances where we collaborate with architects and somebody explodes a CAD drawing with all the hatches that we have. They're like, "Hey man, what happened? Like, we have like 20 other like hatches in there. Like, what are you doing?" Like, especially when we do facade work, some of these details need to be coordinated with the architect. So we'll give them a Revit model with all the facade details that we have. So if he or she needs to change the depth of some member, it doesn't have to go necessarily through us. But when you have TT shades or hatches all over your model, then that's a problem. So yeah, it's pretty straightforward, simple, and it creates pretty clean drawings and easy to use. I love using it for axonometrics. They're my best things. I'm going to talk about this project. This was actually one of the first things that we used Dynamo to bring in data to Revit. And we were given the task to model 24 highways in California. This is for litigation purposes. And we had to get volumetric volumes precisely. And we had to get models in Revit format. So they were like, okay, what are the best formats that we can do this? One is, okay, so what do we have? They only have PDFs to share with us. So we had to extrapolate the information from the PDF and then create those models. So we just use Grasshopper to do this, to iterate through the design. So at every bend, so the highway is built in bends. So you get different connections, and then you need to have booleans, because between those bends, you'll have another element that connects both of them, and they're separate. And besides that, you have like columns with capitals and everything. It has to be modeled correctly. So that was one of the criteria that they wanted to have. So we use Grasshopper because we know we could do Boolean conditional things. So we use that to generate this kind of models, right? Where we are able to, iterate through the 24 different highways. And then at the end of the day, we were baking that into Grasshopper and creating the volumes in there. And we were just using, some of the plugins that exist in Dynamo just to bring those elements. Because imagine trying to build this highway into Revit. It's like, and they wanted like the precise volumes with like the openings and everything. I was like, dude, like, nah. And then we want it next week, and like, nah. So I think it came out to that point where we were using Dynamo to do this. It was like, all right, this is where when I first started using it, I was like, okay, this kind of like works for me, and then it's pretty good if you can do this. So at the end of the day, we just brought the whole information, and we were able to deliver those models to them. And
I've driven on that road.
So bad. That's why. Yeah, but you can do some other fun things. You can visualize elements in there if you want to as well. So I think it's a pretty cool thing to do if you're not a super savvy Revit guy, or like you're in between.
So did you leave all that just categorized as structural? Are those ultimately structural members that were created, or what's the geometry?
There were at that time where there were masses, values,
yeah.
and some of them were actually, like, if you see the actual these elements were the major ones, the bends, and you can see the booleans. These guys were actually pretty important. This too, but they were masses because they wanted to get the information of volumes.
Yeah.
Because some of the things that we're trying to look for was the reinforcement for those elements, whether or not it was too much. So once you get that kind of information out there, you can then go back and do that. But yeah, we used in this case Dynamo. We brought it in and did you can see there, I just created a mass by it. We just surfed through them and then just created that information. And we're pretty happy about that. Another thing that we're doing that I was involved in is this stadium. It's in Rome, SA Roma. So we were able to. So most of this work was done in Grasshopper and some other structural platforms. But everything had to be documented in Revit precisely for the Italian counterpart. So everything that we got built was going to be given to the Italians for documentation and to proceed to finish the project. So we were early in the design, doing most of the design for the stadium, the fabric, seating, and all that. But every time we submitted, we had to submit a detailed model in Revit. So everything had to be coordinated with them. So obviously this is used pretty standard with our group and these kinds of projects, using Grasshopper to come up with different designs, and you can visualize different histories of the model and different states of the design. And we had to coordinate about 3,000 frame elements or structural elements, if you want. This was pretty brutal, but we were using some of the platforms that I was telling you to coordinate this with architects and the Italian folks as well. One thing that we did use Dynamo and Grasshopper was to coordinate line of sight. So if you're in a stadium, you don't want the structure to obscure your view from TVs or the field. And since this building was going for a World Cup stadium, they have to build up even more seating to accommodate for. I think for a stadium to be qualified for World Stadium use, you need a certain percentage of seating, and they weren't meeting that, so they decided to add more seating. So we had instances where the structure was actually obstructing some of the views. So we had to rethink both the seating layout and some of the structure. So we had to come up with different ways to come out with different solutions for those problems. So we were using Grasshopper and Dynamo to do this exercise. And we gave a workshop with Populous, which is a pretty big stadium design, and they have this kind of workflow as well. So it's pretty useful, So like you can do this, or you can do it for if you see it in that logo right there for any building. If you're interior, you can do a line of sight, see if there's any obstruction. But we're using it for seating and confirming that the seating was correct in Revit as well. You can do kind of cool things like visualize elements and add parameters to that element if you need to. We were also in charge of fabricating the roof fabric for this stadium. And I don't know if you ever have tried to build ETFE or saddle roofs in Revit. It's pretty brutal. So especially because our building was not straight. Our building had a 2% slope for drainage and for viewing and for aesthetics as well. So the building was not straightforward. Our massing was changing all the time. So the fabric had to change all the time. So we used Dynamo and we applied a family to create the parameters of the saddle shape. So we use Grasshopper to also create this workflow where we're analyzing drainage flow of the fabric once we had it. And once we had a satisfactory shape that we wanted to have, we would just bring it into Dynamo using just a simple depth parameter in our family. So I'll show you the process. So the process, the process, like for this, is form finding using Kangaroo. I don't know if you've heard of it. So it's this physics engine in Grasshopper that allows you to do this kind of cool form finding shapes in Rhino. So we were using this to write values to a CSV somewhere, right? And all I had to do is wait for the exercise to finish and to have this optimal shape, and then just read that information back into Dynamo using just a basic parameter. So I built for this stadium, I built 3 different families. The first family was like an exterior family and an interior family, and an in-between family, we're calling the saddle shape. So the saddle shape had a depth changer. So that's where the saddle thing will change depth. So as soon as we got some values from that Grasshopper model, we were able just to call out the depth and then change that once the information changed. So you see that right now it's 867. These are millimeters, I think. So, I mean, that's just something that I wouldn't know how to do a couple of years ago without the tool, right? So again, like it said, it's a process of creating an additional tool for you in Revit that you can use or implement things, right? So in this case, like in the first thing was the family for the rebar. In this case, we're just adding a additional parameters to the family that we can change. So and we can read that straight from a CSV file. So at the end of the day, this is what we produce for that stadium. And coordinate that with the architects was pretty crucial, if I would say. This other thing that we did was something with topography. I don't know if you had dealt with topography in Revit, but it's, I mean, I don't know, people don't use it a lot, but this is something that was kind of given to us as an exercise by the architect. So it was us, the architect, and the construction guys who were given the task to see who come up with a better way to get volumes, volumetric volumes from excavating in that site. So we were given a CAD file. We turned that into a topographical map, and then we had a building, right, a mass building. So the idea was, okay, so let's see who else can do this work, seeing how much dirt we need to get out of that information from that CAD file. So it was a pretty fun exercise to have. So we used the Boolean nodes in Dynamo, and we just followed this, and at the end of the day, it just gave you something like this, which is it's pretty cool because if you can do this, you know, at the end of the day, I don't know who won this, who got closer to it. I just got lost in the email, but we were able to know how much cubic feet of dirt there were in the site, you know, and how much, you know, if you can put a price to this, then you can say, hey, this is how much you have to excavate. Can you give me a precise amount of dollars? So, you know, it starts to, if you put monetary things to some of these exercises, then you get people talking about it. The other thing was, how do you then see this kind of exercise where you have a contractor go to the site and do boring tests and see what kind of rock formation you have? This is important for us when we build high rises or any building. So if you have, you know, good soil, then you're good. If you have poor soil, then foundation is going to cost more, right? So some of the things that we're trying to do is how do we take this 2D information into 3D and make it look kind of interesting and useful for everybody else. This is something that's still working on it. But this is the last thing that we're talking, community. All right. So I'm pretty involved in the Dynamo community here. I started it a year ago. We have about 1,200 people in the firm. There's probably 6 who use Dynamo in the whole company. 6 that are pretty like going out there and say like, hey, you should use it. Hey, you should use it for this. Hey, you should use it for that. We give tutorials and all that, workshops like here, but who are pretty active is like only 6 of us, which is kind of sad, but It's fine. I get to do the cool stuff anyways. So we have a dedicated page where we just upload all the information that we have. So this guy is in London. He found a way to export PDFs and DWGs. So people have, you can put comments or questions and then people just answer them. Just like a forum, but for TT specific. Sometimes we'll share the documents and share the information. So some of these can be public. The other thing that we're doing, this is the thing that I was telling you, we have a bunch of tools that we created, but we have a TT palette that this reads Dynamo definitions. So this is a very simple thing that you can do. It's just, if you know how to create a ribbon in Dynamo, it's just a matter of putting in an XML that reads Dynamo definitions. So that's it. It's pretty straightforward. So we have a different things that people can use, like list management examples, read from Excel, adaptive components, things that are, what I've learned is like, if you're gonna do this, put out things that are simple enough for people to go and do it, because otherwise they won't do it if it's too hard, too complicated. If you give them like the definition that I have for that rebar, they'll look at it and they'll go like, oh, you know what, whatever, I'll never do this. But if you give them something that's useful, like simple stuff, then you'll get them, started on it, and they'll be much happier. And the other thing that we do is we create this kind of like just basic things, like what the image of that definition, description, and packages that you're using. This is crucial for people who don't know, the whole thing about Dynamo. You just point them out to this and say, okay, this is what it does. These are the packages that you need. So I created a couple of them, and we try to do them as much as we can for people out there to use them. Changing parameters, and then building custom tools for our groups here as well to visualize, loads on existing building. So this is an existing building. We have a new design, so how much capacity the 16 building has, or it can give you some sort of graphics. We found out that, we've seen more and more that most of our practices wants to see some sort of a graphical thing like this in the reports and stuff like that. So we're trying to do things that do graphics as well, like 2D graphics, like this kind of element. The other thing is just building tools for a company, right, or for engineers as well. Dynamo SAP. And I think I'm just going to show you a couple of things that we're doing so far. I don't know if that's time. Is it time?
It's a couple minutes.
All right.
Yeah, go ahead.
So this is Constru. This is open source. You can beta this. You can access this. So what does it do? This is sort of like a TTX. So you can use this to connect to different platforms if you need to. You can go to Revit, to Grasshopper, to Excel. I don't think you're using any of the other ones. So you can use that and create models and update those models in the web if you want them to. And you can invite collaborators to that platform and add and change elements. So something that it looks like this, you download this information, you create an account, and it takes you to a website that you can always access those elements. This is something that it looks like. So it's a web viewer for BIM. And you can create a history of elements that got changed and visualize them in the web. Another thing that we're developing is Mirar, which is another web interface that would allow you to visualize, elements from Revit or Grasshopper, whatever, and just have some sort of intelligent platform that allows you to see that information. I know a lot of people are building now web interfaces. We're getting into it. It's cool. It's fun. So yeah, this is another platform that's coming up soon. The previous platform to this was Spectacles. It's free. You can use it. If you have any questions, just shoot me an email. This is another platform that we're trying to put out soon. It's called Foxtrot. So we're using this to visualize, live elements or at least prototype elements in your environment. So this is taking a tablet, and if you create a massing or some sort of a geometry, then you can visualize this in whatever environment you have. This is pretty beta right now, but we're testing this out as well. So yeah, you can walk around and visualize what it is. And I think this is gonna come out. I don't know. We'll see. But I mean, this is all revolving BIM. Now, if you can do all those in Dynamo and stuff like that, just put them up on their web.
Nice tagline.
Yeah, that's it. That's all I have.
Wow, that's fantastic.
Yeah.
We saw your little handout here. Is most of those tools mentioned in there, or
Some of them, yeah.
if there's anything you want me to post to the group, just send me an email and I'll put the links in in the summary at the end.
Yeah. I can send you some of the stuff. I think we were trying to come up with a new one, but I didn't have time.
Yeah, no, it's fine. I'm just saying if any of those like things you were showing at the end.
Oh yeah. These ones are still
things.
the Foxtrot is still like internal, but the other ones we can send that out.
Sure.
If you want to be
whatever you want me to put in the because when I post the recording, there'll be a discussion post that goes with it, and I can add any of those links in there.
Yeah, I mean, we're trying to find beta testers for all these platforms, so feel free.
So, anyone?
We're also, I think I might be able to send you some of the definitions that we're using here.
Okay.
So, whatever you guys need.
Just a quick question. Do you have one add-on for the LC analysis? My lead colleague was asking if there is an add-on in Revit for LC analysis for the carbon footprint. You mentioned that.
No. You mean native? No, that's for the carbon footprint.
Yeah. Or LCA life cycle assessment for the lead.
Yeah. Do we have an add-in for that?
Yeah.
No. We're doing that work after we get the Excel. We have some applications that do it, but that's just internally for calculating. We have something that calculates carbon footprint based on your your concrete strength, design, and all that. But
Thanks.
Yeah, you're welcome. Any questions?
Well, that was terrific. Thank you. You guys are really covering it from a lot of different angles. It's awesome.
I mean, yeah, that's what happens when you get all these problems, and you're like,
well, I guess that's you benefit from the scale of your firm there because your group you said was about 20 people, but you're serving 1,200, so you get exposure to a lot of different kind of problems. So that's really it's a cool environment.
Yeah, one thing that we're still struggling is finding a way to bring in point clouds. That's something that
when you solve that, let me know. We'll have you talk again.
I don't know. That's a hard one, man. That's something that it's not on our end. It's on the end of Revit.
You could stop that because it's gonna